Hello viewers, welcome back. Today I am going to demonstrate how to use multiple modules to find y value for any x value using linear interpolation. So basically we'll be doing linear interpolation, but for that we'll use multiple modules. So here we have a set of data. In column A we have x values, and in column B we have corresponding y values. First of all, let me demonstrate what I'm going to do, and later on I'll explain. So we'll insert a target value of x here, okay, which is not in the table at the moment. Say let us input a target value of 5.5, and we want to get the interpolated y value using the Excel VBA program on the basis of this data set. Okay, so let us now click on this command button, interpolate y, and that should give you the answer. That is, the interpolated value is 55. Okay. So how did you do it? The steps involved are actually there are 5 steps involved. First of all, what we did is this is your xy coordinate. Okay, we know the x value, but we don't know the y value. Okay, so what we did is, first of all, we found the nearest lower x value, that is x1, and then we found the nearest higher x value, that is x2, from the range of this data set, of course. And after that we found the y1 value, that is corresponding to x1 value, and then y2 value corresponding to x2 value, and after that we linearly interpolated to find the y value using this equation. Okay. Right, so I've inserted the x value here, and we have found the interpolated y value, that is the result, in this cell. But meanwhile, what this program did is actually it found the nearest lower x value, that is x1, from this range of data. For example, the target value is 5.5. So first of all, we populated all the x values which are less than the target value, that is 5.5. So if you look at the data here, the target value is 5.5, and all the values less than 5.5 are 1, 2, 3, 4, 5. Okay, this is rather a simple example, but this will work for any other example. And also we found the nearest the values greater than x values, that is the target value 5.5, and these are the values greater than x. Okay, if you go to the column here, so 5.5 is the target x value, and the values greater than this target value are 6, 7, 8, 9 to 12. Okay, so these are all populated here, and what we did is, out of these values less than x, that is 5.5, we found the maximum one, and that should give you the nearest lower x value, x1. Okay, and out of this data, that is all the values greater than x, we found the minimum one, and that should give you the nearest higher x value. Okay, that is x2. And then the program searched in this table that if this is x1, what is the corresponding value of y, that is y1. So that has been put in this cell, and the corresponding value of x2, that is corresponding value of 6, is corresponding y value of 6 is 60, and that has been put here. So since 5.5, it is quite understandable. If you know the value of x and y1 and x2 and y2, the value corresponding, the interpolated value of y corresponding to x value, that is 5.5, will be between 50 and 60, and which is 55. Okay, all the data here are actually linearly related. Okay, so this is what this program is doing. So, and there are 5 steps involved in developing this program. So what we did is we actually used 5 modules here, okay, in the program. Let us go to the Visual Basic editor, okay, and for each of these steps I have used 5 modules. I talked about modules and the concept of modules in my last lecture. You must have seen the lecture and understood it. So this is how you know how to insert the modules. You have to go to the insert tab and then click on the module, and you can insert as many modules as you want. Okay, so here I have used 5 modules. In module 1 I have written a macro or sub-procedure or subroutine, whatever you want to say, and I have named it x1 value so that I can easily understand what this subroutine is doing. And I have used 1, 2, 3, 4, 5 variables: I, j, row count, x, and x1. X is the target value, and x1 is the nearest lower x value. Please try to remember all these things, and I have declared the variable types correctly. I, j, and row count, these are all integers, and x1 may contain decimal places, so I have declared them as double type of variable. So in order to find the row count, that is how many rows are there in the data set, that is let me make it smaller so that we can see both. In order to find the row count, that is how many rows are there in this data set, there are 13 rows. There may be 14, 15, and whatever. So in order to count the row numbers, I've used a variable that is row count, and I've used this worksheet function. You know how to use worksheet function in Excel VBA. I have demonstrated earlier in one of my lectures that application.worksheet function and then count A, right? Range you declare from A to A, that is in column A. Okay, so that will count you or give you how many rows are there in column A. Okay, and x, how to get this variable or the value of this variable x is in cells 5, 7. That is a user input. See, this is the cell where you are inputting the value, the target value x, and it is located in row number 5 and column 1, 2, 3, 4, 5, 6, 7. So this is the location of the cell. Okay, so x you'll have to find from cells 5, 7. And then let us write our code. Cells 1, 11, we have said values less than x. So 1, 11, this is the 11th column. The k column is 11th column. So in the first row of column 11, we are writing what? Writing values less than x. So this header is actually written from the Visual Basic Code. You could write it yourself right over there, but just to demonstrate that even you can write the headers from Excel VBA, I have added this line. Okay, now we are going to run through the data set in order to find the nearest x value to our target x value, that is, which is 5.5 in this case. So for I is equal to 2 to row count, so we are running through all these data rows. Okay, so the first row starts from 2 and the last row is the row count. Okay, the end value of this loop will be from 2 to row count. And if cells I1, that is if any cell value is less than x, if it is less than x, that is in this case if it is less than 5.5, that will be written where? That will be written in column 11. Okay, so you are saying cells J11 is equal to cells I1. So that value in column A will be written in the column K, that is in column number 11. And J we have initialized a value of j is equal to 2, so the first value will be written here and the next value will be written where? J is equal to j plus 1. So when it will loop through the value of I again and satisfy this condition, the next value satisfying this condition will be written in the third row in column K. Okay, so this is how it will fill up the values in column K sequentially. Okay, and all the values less than 5.5 of the target X value. And after that, what we are doing is we are from the data populated in column K or in column 11, whatever you want to say, we are finding the maximum value, and that will give us the nearest X value to the target X value. That is, we are finding this X1 value. So the maximum of these values, which is 5 in this case, should be the nearest value to the target X value. And for that, to find that, we are using, this is our X1 variable, and we are using the worksheet function again like before, and here we have used the maximum work function, that is max work function, and the range is K to K. Okay, that is the all the values in column K. Out of all the values in column K, it will find the maximum value, and that should be equal to X1, and we want this X1 value to be written in cells 5-8. So what is cells 5-8? Cells 5-8 is this one. So here we have written, or the program has written, the value of X1. So that is what this module is doing. It is finding the nearest lower X value. Okay, nearest lower X value. For that, it has populated all the data less than the X value in this column, and from this column it has found the maximum value, and that is the X1 value, and that has been put in this cell. Okay, that is what this module is doing. Similarly, we have written another module that is for X2 value with the similar logic. If you just run through it yourself, you'll understand. It is almost the same thing. What we did is we populated all the data which are greater than 5.5 of the X values in this column, in column L or in column 12. You'll see in the code, and out of these populated values in this column, we have found the minimum value, and that gives us the nearest X value to our target X value, and that is in this case is 6. Okay, right. So if you run through it, you'll see all these things are self-explanatory now, because you have clearly understood the module 1. So there should not be any problem in understanding module 2. Instead of populating the data in column 11, here we have populated the data in column 12. Instead of finding the values less than X, we have found the values greater than X. And instead of finding the maximum value out of the range or the populated data, here we have found the minimum one to find the nearest higher X value. Okay, I hope you understand it, and I always suggest that you take a notepad, take a pen and write it yourself to understand each of the lines. So this is your whole data. Okay, if you like to see it, hold your screen and go through each of the lines to see what these few lines of codes are doing. Okay, similarly you can see module 1 in a bigger screen, right? Take a closer look, go through each of the lines, take print screenshot if you like, and see it in another photo editor application. Okay, now let us go to this module 3. So we have found, we started with 5 steps, if you remember, to complete the task. First of all, you'll have to find x1, then you'll have to find x2, and these two variables we are finding in the 2 modules, that is module 1 and module 2. And now in module 3 we'll be finding y1 value corresponding to x1, and in module 4 y2 corresponding to x2, and in 5 we'll do the final task. So in the module 3 now we are finding y1 value You see this is the correct way of writing big programs. When you have many steps involved, always try to split the whole program into small little modules or the building blocks, as I explained in my last lectures. This is always better to write in this way. That will involve less mistakes, and it will always be easier to trace back the problem. Okay. So here also we have declared 1, 2, 3, 4 variables, I, row count, and of course you need x1 variable, because you'll find the corresponding y1 variable on the basis of this x1. So row count is again count a worksheet function that has been used, and x1 is in cells 5, 8. We have already done it in module 1. Okay. And we'll just pick up that value now and we'll use it here. So we'll run through each of the lines of the data set from 2 to the row count, that is to the last row where the data are involved. And we have put a simple logic here. If cells I1, that is if a value in column 1, that is in column A, if any value of any cell in column A is equal to the x1 value, okay, x1 value, then do what? Then y1 is the value in the column 2 in the same row. Okay, so if cells I1 is equal to 1, say this one, if cells I1 is equal to x1, that is 5, then y1 will be this one. That is the value in cells I2 in the same row, but in the second column, that is in column B. Okay, and then we are telling Excel VBA to store this y1 value in cell 7, 8, which is what? Which is this cell. Okay, this is 7 and this is 8. Okay, so the value y1 value is stored or written in this cell. Similarly, in module 4, we are finding the y2 value, exactly the same logic, no difference at all. So instead of writing, so here instead of declaring x1 and y1 value, we'll be declaring x2 and y2 value, because we want to find the y value corresponding to x2 value, and these have been declared as double type variable, because these values might have decimal places after the decimal point, so they have been declared as double type. And we have again calculated the row count using this count a function. You know how to use a worksheet function. Okay, I have showed you earlier. And x2 is the value written in cells 5, 9. Okay, we did it in module 2. x2 is written here. Okay, and we are running through, by using this loop, we are running through all the data rows from 2 to row count, and we have used a simple logic again. If cells I1, that is if the value is equal to x2, then take up the corresponding value in column B as y2. So that is what this line of code is doing, and we have stored this y2 value in cells 7, 9, that is here. Okay, this is 7 and this is 9th column. Very simple. When you split the task into small modules, this is always handy and easy to understand, easy to follow, easy to trace down, trace back, whatever you want, and always easy to debug your problem if there is any. Right. Then, so you have already found all the required information, that is x1, x2, y1 and y2. So now our next task should be to interpolate. So what we did is we added another module for the step 5, and here we are using all these variables. So dim x as double, y as double as well. This is what we are trying to find. That is our whole mission. That is the whole mission about. And x1 and y1, x2 and y2 we have already procured. So we know this, we know this, we know this, this and this. We don't know this one. So where is x value? X value is in cells 5 7, x1 in 5 8, y1 in 7 8, x2 in 5 9, y2 in 7 9. And how to find this y value? This is linear interpolation. Very simple. Anyone of science background should not find it difficult how to get an extrapolated value, especially when the data set has linear relationship, right? So this y is equal to this. The equation is written here, and that has been actually expressed in terms of VBA language. So this is y value, and we have written this y value in cells 7 7, that is in this cell. Okay, so these are the modules we have written. And now let us go step by step. I'll refresh. I'll see. I'll show you what I have written behind this command button. I'll refresh all the data. Okay, and I'll go to let us insert the target value again, 5.5, and go to the Visual Basic editor, and I'll run all these modules manually now. So I'm going to click on this run button or the F5 button, whatever you like. So click on this run and minimize it, or come out of this editor window, and that module will give you only the x1 value. So what it has done, it has populated all the values less than 5.5 in this column and found the maximum from here, and that has been put or placed in this cell. Fine. Let us go to module 2 now. Okay, I'm running all the modules individually. Later on I'll show you how to run all these things together. So click on this module 2. That will find the x2 value for you. Done. And see, the x2 value has been put here. What it has done, it has populated all the values greater than 5.5 in column L, and from these values it has found the minimum one, and that is your x2 value, and that has been done by the module 2. Okay, and then we are going to go to module 3 to find y1 value, and let us run this one, and that should give you the y1 value. Okay, what this module has done, corresponding to x1 value, that is x1 value is 5, it has found the y value, that is y1, and that has been put in this cell. Okay, and go to the module 4 again, module 4 now, not again, and click on this run button, and that should give you y2. So what this has done, this has found this x2 value in this A column or column 1, and the corresponding y value is y2, and that has been put here, right? And now if you go to the module 5 and run this macro or subroutine, that should give you the y value, and that is your interpolated value, and that is what you have been trying to achieve. Okay, so following all these steps and using 5 modules in this program, you have finally found the interpolated value. Okay, now how to get all these things under one button? Okay, you can't open all the modules one by one, run each of them and get your desired result. That is not the way you should be developing your applications. Okay, so what I did is I've demonstrated you in my last lecture as well. It is always better to understand the modules and use them properly. So what I did is, under the command button 1 and click action, I have written these few lines of codes. What these codes are doing, I am calling, let me indent. Okay, so first of all I am calling the module with sub procedure or the subroutine x1 value. So I am calling x1 value subroutine from this command button. That is this module, this subroutine is in where? This subroutine is in module 1. okay, and that gives you what? That gives x1 value, okay. So this is module 1, and I'm calling the next subroutine or the sub procedure, and that means I am calling actually the module 2, okay, and that gives you x2 value, okay. And I'm calling module 3. You see how these things develop, okay. Always try to go step by step and be patient. Don't rush. If you rush, you will not learn, okay. So the module 3 will give you y1 value. Calling y2 value means I'm calling this sub procedure, okay. See, if you go there in say module 4, what is the name of this sub procedure? Y2 value. You have to write the exactly the same name of the subroutine here. If you misspell it, or if you don't write it correctly, it will not find the subroutine and it will not work. So the name of the subroutine in the modules has to be exactly the same in the calling program. So we usually call this a calling program, because this program is calling some of the subroutines written earlier, okay. So this is module 4, and in the final one, that is the y value, that means we are calling module 5, or we are using the sub procedure written in module 5, and what is the name of that subroutine? That is y value. So we are actually using the code written in module 5, okay, understood? So all the subroutines, all the modules are now under the command button 1, and once you click it, this command button will call all these subroutines one by one and do the necessary calculation in a blink of an eye, okay. So let us close it now. Let us refresh it. I'll show you what I have written under this refresh button. So this refresh button will actually clear all the earlier calculations, okay. See, everything is cleared, even the headers are gone, okay. So now if you click on this interpolate button, because you are now calling all the subroutines in the modules, so this should do the work instantaneously, all together simultaneously. It has not done anything because you have not put any target value, so we'll have to refresh it again. No problem, we have this refresh button, and that is always at your service, so use this target value. And now if you interpolate, that should do everything together, okay. It has done x1, it has found x1, it has found x2, y1, y2, blah blah blah, and also put the interpolated y value in this cell. So all these 5 different steps are now called from this single button. That is, it is calling all the subroutines in the 5 modules and doing all the necessary calculations to give you the interpolated value. That is very nice, actually. That is very interesting, okay. So in this way you can write a very large Excel VBA program if you want, okay. Now let us see what we have written behind this refresh command button, okay. So I'm going to design mode and double click on this refresh button. Oops, right, okay. So this is your command button 2, and what I've written, I have made all the cells blank. So cells 5, 7 is blank, cells 5, 8, wherever there is, all those calculations involved, that is x value, y1, x1, x2, y1, y2, okay, and the linearly interpolated y value in all these cells, okay. In all these cells, I have told the program to make all these cells blank. So how to make it blank? Just put double close commas. That is all right. And also you can make all the data in columns from K to L in these 2 columns. In these 2 columns where we are storing the values less than x and values greater than x, all these cells, all the cells in these 2 columns are also made blank. So it is refreshing all the data just by using this simple coding, right? So that makes it very interesting. Now we can go further, actually. If you don't want to if you don't want to call all these subroutines from here, okay, and also well, let me go to this module 5 first, the interpolation, where we are doing the interpolation, right? You may not like to write this x value is equal to cells 5 7, x1 is equal to 5 8, y these things, okay. Instead of picking up the variables from the cell locations, what we could do is, because we have already obtained the values in module 1 2 3 4 and all these things, we could actually in the module 5 we could call all these 4 programs, 4 subroutines here, and get all the x x1 x2 and y2 values. Let me show you how to do it, okay. Let me think about it, what I'm trying to do, okay. So we'll have to do what? We'll have to y is okay, okay. So we are going to call, okay, we are going to call here, we are going to call, we don't want to get all these values from the cells, we are going to get all these values from the relevant modules or the subroutines in the modules. So we are going to call x1 value subroutine, that is in module 1, and from there we want to get the value of x, because we used the target value x in there, and we also want to get the output of that subroutine, okay. So we are going to that is why we have written these 2 arguments against this call subroutine, okay. So this is your this is your calling subroutine now, and we are calling some other subroutines. And first of all, we are calling the subroutine in module 1, okay, in module 1, which is named x1 value subroutine, and from here we are trying to get 2 arguments, the values of 2 arguments, one is x and another is x1. So we are going to get this from module 1. Similarly, we are going to get the value from value x2 from the x2 value subroutine, which is in module 2, and y1, from y1 value we are going to get y1, okay, and from y2 value subroutine we are going to get y2, okay. So instead of picking up the data from the cells, you don't have to look for the cells again, okay. So you can call the values from the corresponding subroutines. So because you are calling from here, so this subroutine will be called the calling subroutine, and others are from where we are calling, okay. Now because you have used these arguments in here, you don't have to declare it there, okay. You don't have to declare this x here, y you have to declare, okay, and x1 y1, x1 is there, y1 is there, so you don't have to declare it here. The arguments you put in the calling subroutine, you don't have to declare it, okay, and also the x2 and y2 you don't have to declare, okay, right. So don't declare those because these are already in here, okay. And let's try to run it and see if there is any other mistake, okay. Should we run it from here? Okay, right. So I'm going to close it, refresh, and let us put this 5.5 and go to Visual Basic Editor window and go to module 5, and let us try to run it and see if it works. If it doesn't, we'll repair it, no problem. So it is saying that wrong number of arguments or invalid property assignment, okay. So there is a compilation error, no problem. Don't puzzle. Let us go to this module 1, and now in the module 1 you'll have to also write these arguments. Okay, the arguments or the values of the arguments that will be transferred to the calling program, you'll also have to write it here. And once you write these arguments here, you don't have to declare the variables. Okay, and similarly in module 2 also you'll have to correct it. So from module 2 you are going to transfer x2, and you don't have to write this. Okay, and from module 3 you are going to transfer y1, so you don't have to declare this variable here. And from module 4 you are going to transfer y2, so you don't have to declare this variable in this sub procedure. And let us now try it again, and let's see if it works. Okay, so we are now in module 5 and we are calling all the 4 subroutines written in module 1, 2, 3 and 4, and we are also calling those subroutines to transfer these variable, the values of these variables to this program or to this subroutine. Okay, so let us see if it works now. Right, okay, click. Okay, it has not shown anything, no error, so probably it has done the job. Yep, see, that is a beauty. Let me show you again. Refresh. Okay, try with another value, 6.5 instead of 5.5 now, and go to this editor window. Keep on this module 5, that is the y value subroutine, and click. And click. .5 is there. Go module 5. Okay, I must have done the job. Yes, so the 6.5 is your target value now. The nearest x value is 6. Okay, and the nearest higher value is 7. The corresponding y1 value is 60, and the corresponding y2 value is 70. Right, and the interpolated value is 6.5, which is quite understandable from this data. Right, so now because you got the result just by clicking on module 5, that is your y value subroutine. So instead of calling all the other programs from this button, we are going to delete all these things. We don't need. We are going to call y value only, y value subroutine only. Okay, so refresh, write 6.5 again, and click on this command button now. Piece of cake. Okay, it's doing the same job but in a different manner. In fact, this is a smarter way of doing it. I hope you have understood it. Just to show you again, in the module 5, in the y value subroutine, we have declared only one variable, that is y as double, because you want to get this result, so that has to be declared here. And all the other relevant parameters for this linear interpolation equation, okay, you need the value of x, and that should be from, that you can find from x1 value subroutine. You want the value of x1 that you have calculated in the in the x1 value subroutine. You need x2 value that has been calculated here in this subroutine, that is in module 2. You need y1 value that is in y1 value subroutine, and that is in module 3. You need y2 value, and that is in y2 value subroutine, and that is in module 4. So you have called all these subroutines to transfer these parameters, and also in the subroutines you have written these arguments so that they can communicate with each other. So whatever arguments you want to call from the main program or from the calling program, those arguments should also be put within the close parenthesis in the sub statement. Okay, if you don't do it, they will not talk to each other, they will not communicate with each other, and nothing will happen. Okay, I hope you have understood the demonstration clearly, and this is a very useful tutorial, I believe. I mean, at least from my experience, I can tell you this is a very useful tutorial, and if you understand it clearly, you will be able to develop very complex programming, very complex Visual Basic applications in your real life, in your office, in your job, in your personal life, and for your organizations for many different purposes. Okay. Thanks very much. Thanks for watching this. Very shortly, I'll come back with more Excel VBA tutorials.